In the last video, we learned a lot of basic ideas about sets. In this video, we're going to look at two different important ways to write sets. Most of the sets we saw in the last video were given like lists. We simply listed the elements of the set, and if there was a pattern we saw that helped us express that list, then we used dots to represent it. For example, here's the set of all letters in the English alphabet, where we assume that the pattern here in the dots is understood. When we express a set by simply listing its elements inside curly braces, this is called writing the set in roster notation. The word roster in everyday language means a list too, usually of people. For example, the starting 11 of a football team or the members of a college class. And that's the meaning we adopt here for sets. Roster notation is simple, but it can sometimes hide information about why objects are the elements of a set. For example, look at this set. There are dots at the end, but what exactly is the pattern here? We'd like this pattern to be more easily understood by someone reading it. In fact, the pattern is that every element of the set is a natural number that is equal to 1 mod 6. It might be clearer just to say that. In other words, this is the set of natural numbers that are equal to 1 mod 6. Being explicit about the membership requirements here makes it a lot easier to understand this set. Here's an alternative way to express this set that makes the membership requirements clear. Here's how to read this. The curly braces mean the set of. Before the colon, we have a variable and it states the domain of the variable. So this means the set of all n in the natural numbers. Then the colon means such that. And then after the colon, there is a predicate, n mod 6 equals 1. So in all, this notation reads the set of all natural numbers n such that n mod 6 is 1. That's an economical way of writing the set we started with that specifies the elements of the set not by listing them, but by giving the requirements for membership. This kind of notation is called set builder notation. In set builder notation, instead of listing the roster of elements, we build the set by stating the rules for membership. What we're doing here is starting with an initial set, all natural numbers, and then using a predicate to filter out all but the elements that we want to keep. We first list the variable and its domain, and then after the colon, we list the predicate that filters out elements. Here's another example of set builder notation, the set of all real numbers such that x squared equals 1. What's this set in roster notation? Well, we start with the entire set of real numbers, which is a huge set, but then we use this predicate to filter out most of them. We're only going to keep the real numbers that make this predicate true, which is just x equals 1 and x equals minus 1. So this set in roster notation is the set consisting of 1 and negative 1. And here's another example, the set of all x values from the set 0 through 6 whose square root is bigger than 2. What's this in roster notation? Start with all the elements of the set 0, 1, 2, 3, 4, 5, and 6. That's 7 numbers. Now apply the predicate to filter out. The numbers that meet the membership requirements that make the predicate true are just the numbers 5 and 6. So that's our set in roster notation. In other words, when we write a set in set builder notation, we're expressing it as the truth set of a predicate, namely the predicate that comes after the colon. What comes before the colon is the initial set before we apply the filter. Then the predicate does the filtering. Now you try it. Here's a set in set builder notation, and just in case you didn't know, a vowel in English is any one of the letters A, E, I, O, or U. So pause the video and write out this set in roster notation. So the initial pre-filtered set we use is the set of letters A through M. Notice that's not the entire alphabet. Then we filter out everything except the letters that make the predicate X is a vowel true. That leaves us with just 3 letters, A, E, and I. Now try going the other direction. Here's a set that's in roster notation, and choose any of the following that would be correct set builder notation for the same set. So there are 2 correct answers on this one, and here they are. Both of these, as you can check, produce the same list of numbers, and both are equally correct, although this one is shorter. The other 2 are not correct, and I'll explain why. This one is not correct because the set we start with prior to the filtering is wrong. This would be the set of all integers, and if we started with that set and filtered out all but the ones that are 3 mod 10, we'd pick up not only all the numbers in the set you see at the top, but also a bunch of negative numbers. So that starting set really matters. It has to be stated and stated correctly. This other one is incorrect because it has the predicate listed first and the initial set second, and that syntax doesn't make sense. If you read it aloud, it says the set of n mod 10 equal 3 such that n is in the natural numbers. That doesn't make any sense in English, and so it also doesn't make any sense in math. Correct set builder notation of this type does not list the filtering predicate first. You can't, because we have to have a set of numbers to filter first. So be mindful of the syntax you use to write sets in set builder notation. However, and finally, there's a variation on set builder notation that can be handy for programming purposes. Sometimes we can write a set in terms not of filters, but in terms of computations that we perform on elements in a set. For example, this set is also considered to be in set builder notation, but it's different. We're not starting with an initial set and filtering things out. Notice the expression before the colon doesn't declare the variable and its domain like we saw a minute ago. Instead, it gives a computation to perform, in this case, squaring, and then it gives the variable and its domain. Now, what this alternative set builder notation means is perform this computation over all elements of this set. It's still building the set in terms of rules for constructing the elements, so that's why it's considered set builder notation. But instead of starting with the set and filtering out, we're starting with a computation and stating where to apply it. This is basically a for loop. It means loop through all the elements in this set after the colon and perform this process on them. Or in another programming metaphor, instead of using a predicate to filter out elements, we're using a computation and mapping the computation over a set. In this case, we're mapping the computation of squaring over the entire set of natural numbers, and that gives us this set in roster notation in the end. So in this video, you learned about roster notation and set builder notation and the differences between the two, and got some practice switching the expression of a set from one notation to another. Good job. In the next video, we'll get a little more practice with this from the standpoint of deciding whether an object belongs to a given set or not.